Tonight on The Future of Everything, we've got 3i Atlas updates and maybe even our best shot yet to clearly see the third interstellar object ever detected passing through our solar system.
It's not an asteroid from our solar system. It's something far older, faster, and completely alien. And NASA says if 3i-ATLAS even grazes the moon, the consequences could be catastrophic. In recent months, astronomers have been closely observing 3i Atlas, an interstellar object believed to have originated from outside our solar system, only the third of its kind ever detected. Unlike Oumuamua or Borisov, this one's trajectory brings it alarmingly close to the moon's orbital path. NASA's simulation teams are now running impact models, and what they've found is astonishing. A lunar impact by 3i. Atlas could release more energy than the largest nuclear arsenal on Earth combined, sending shockwaves across space and altering the moon's surface forever. Don't look away. This story might be the first real test of how prepared humanity is for an interstellar threat. Meet the interstellar intruder. Imagine a visitor from the depths of space, a traveler that's been drifting through the galaxy for billions of years. That's exactly what 3i Atlas is. Discovered on the 1st of July 2025 by the Atlas Telescope System in Chile, this interstellar comet isn't just passing through our neighborhood. It's the third confirmed object from beyond our solar system ever spotted by astronomers. This cosmic snowball is somewhere between 1,444 feet and 3.5 miles across, based on observations from the Hubble Space Telescope. To put that in perspective, we're talking about something potentially larger than many mountains here on Earth. When it was first spotted, 3i Atlas was already cruising at an incredible 137,000 miles per hour, moving so fast that the sun's gravity can't even hold it. That's what scientists call a hyperbolic trajectory, meaning this comet came from interstellar space and will eventually return to it, what makes 3i. Atlas truly special is its origin story. Tracking its path backward through space, astronomers discovered it came from the general direction of Sagittarius, where the center of our Milky Way galaxy lies. This visitor has been wandering through the cosmos for an estimated 3 to 11 billion years. Think about that for a second. This chunk of ice and rock might be older than our entire solar system, carrying secrets from a distant planetary system we may never see. The comet's current journey. Right now, as you're watching this video, 3i Atlas is still traveling through our solar system. It reached its closest point to the Sun on the 29th of October, 2025, coming within about 126 million miles of our star. That might sound far, but in cosmic terms, it's actually between the orbits of Earth and Mars. During this close approach, the comet was temporarily hidden behind the Sun from our perspective here on Earth. NASA and space agencies around the world have been tracking this visitor intensely. Multiple spacecraft, including NASA's SPHEREX, the James Webb Space Telescope, and even the Hubble Space Telescope, have all turned their instruments toward 3i Atlas, the Transiting Exoplanet Survey. Satellite detected activity from the comet as early as May 2025, 2 full months before its official discovery. These observations have revealed something fascinating about what this interstellar visitor is made of. The comet is releasing incredible amounts of carbon dioxide, water, carbon monoxide, and even water ice as it approaches the Sun. In fact, 3i Atlas has one of the highest ratios of carbon dioxide to water ever seen in a comet. This unusual chemistry tells scientists that the planetary system where this comet formed might have a very different makeup than our own solar system. It's like getting a postcard from another corner of the galaxy, showing us how different planetary neighborhoods can be. Why there's no real collision risk? Let's address the big question right away. Could 3i Atlas actually hit the moon? The simple answer is no, and here's why. NASA has calculated the comet's trajectory with extreme precision and the numbers are clear. The closest 3I Atlas will come to Earth is about 170 million miles on the 19th of December 2025. That's roughly 1.8 times the distance between Earth and the Sun. The Moon orbits Earth at an average distance of only 238,855 miles. Do the math and you'll see that 3I Atlas is passing nowhere near the Moon. It's not even in the same cosmic zip code. NASA's planetary defense teams, who monitor potentially hazardous objects constantly, have confirmed that this interstellar visitor poses absolutely zero threat to Earth or the Moon. The trajectory is so well understood that astronomers can predict where it'll be decades from now. But here's where things get interesting. What if we're just speculating? What if somehow, against all odds, an object like 3I Atlas did change course and head straight for the Moon? That's the question that makes this exploration so fascinating. Understanding what would happen helps us grasp the incredible forces at play in our solar system and prepares us for monitoring future space objects. The physics of a lunar impact. When an object hits the Moon, the physics involved are absolutely mind-blowing. We're not talking about a gentle landing, we're talking about a hypervelocity impact where forces become so extreme that normal rules almost don't apply anymore. Objects hitting the Moon typically travel between 12 to 72 kilometers per second, which translates to roughly 27,000 to 160,000 miles per hour. At these incredible speeds, the energy released during impact isn't just explosive. It's catastrophic on a scale that's hard to comprehend. Scientists estimate that the kinetic energy from such an impact can be many times more powerful than conventional explosives. We're talking about energy levels that can instantly vaporize rock, create shockwaves that travel through solid stone, and generate temperatures hotter than the surface of the Sun. The Moon has no atmosphere to slow down incoming objects. Unlike Earth, where our protective blanket of air burns up most meteoroids before they reach the ground, the Moon gets hit with full force every single time. This is why the lunar surface is absolutely covered with craters, from microscopic pits smaller than pinheads to massive basins hundreds of miles across. The Moon's face tells the violent story of billions of years of cosmic bombardment, crater formation on the Moon. If 3I Atlas, measuring potentially up to 3.5 miles across, were to strike the Moon, the resulting crater would be absolutely enormous. Scientists use something called crater scaling laws to predict the size of impact craters. Generally speaking, the crater diameter ends up being roughly 20 to 30 times larger than the impacting object itself. So we'd be looking at a crater potentially 60 to 100 miles across. The formation process happens in distinct phases that unfold in mere seconds. First comes the compression phase, where the comet slams into the lunar surface and compresses the rock beneath it. The impact creates temperatures so high that both the impactor and the lunar rock beneath it instantly vaporize and melt. This isn't like heating something in an oven. This is an instantaneous transformation from solid matter to superheated plasma. Next comes the excavation phase. The compressed material rebounds violently, sending shockwaves racing outward through the lunar crust. These waves carry enormous energy, fracturing and pulverizing everything in their path. Material gets thrown upward and outward in massive plumes, creating what scientists call ejecta. This material can travel hundreds or even thousands of miles from the impact site, creating bright rays of debris that extend across the lunar surface like spokes on a wheel. The immediate aftermath. The moment of impact would be one of the most spectacular events visible from Earth in human history. Observers on the night side of our planet would likely see an incredibly bright flash, as the impact released energy equivalent to thousands of nuclear bombs. The flash would be caused by the instant vaporization of both the comet and lunar rock, creating a brief but intensely bright fireball visible even without telescopes. Following the initial flash, a massive plume of vaporized rock, dust and debris would erupt from the impact site. This plume could extend hundreds of miles above the lunar surface, creating a temporary cloud that would be visible through even small telescopes. The material in this plume would be moving at tremendous speeds, with some particles achieving escape velocity and breaking free from the moon's gravity entirely. The impact would also generate what's called a seismic moonquake, sending vibrations through the entire lunar body. While we don't have seismometers on the moon anymore since the Apollo missions ended, scientists estimate that a major impact could create moonquakes detectable across the entire lunar surface. These vibrations would cause the moon to literally ring like a bell, though in the silence of space, this ringing would be silent to our ears. Debris, heading toward Earth. Here's where things get really interesting for us down here on Earth. When material gets ejected from a lunar impact with enough force, some of it can escape the moon's gravity and head our way. Based on research from Western University, particles ranging from large sand grains to sugar cube-sized chunks could reach Earth anywhere from a few days to a few months after the impact. These lunar fragments would be traveling incredibly fast, creating what scientists describe as an intense and spectacular meteor shower. Imagine looking up at the night sky and seeing not just a few shooting stars per hour, but potentially hundreds or even thousands. The debris would burn up as it entered Earth's atmosphere, creating brilliant streaks of light across the sky. It would be one of the most amazing celestial displays in recorded history. The good news? There's absolutely no danger to anyone on the ground. Earth's atmosphere is an incredibly effective shield. Even particles traveling faster than speeding bullets would burn up completely before reaching the surface. We might get fragments no larger than grains of sand making it through, but these would be harmless. It would essentially be like a very intense but beautiful fireworks show courtesy of the moon, satellite, and space infrastructure concerns. While people on Earth would be safe, our satellites orbiting the planet might face some serious challenges. According to space debris experts, the impact could send hundreds to thousands of millimeter-sized pieces of lunar material toward Earth. These fragments could affect our entire satellite fleet, potentially causing what amounts to 10 years' worth of normal meteor debris exposure compressed into just a few days. Modern civilization depends heavily on satellites for everything from GPS navigation and weather forecasting to communications and internet connectivity. A piece of lunar debris traveling at extreme velocity could damage solar panels, puncture fuel tanks, or destroy delicate sensors on satellites. It wouldn't be like the catastrophic Kessler syndrome scenario where debris creates a cascading chain reaction, but it could still cause significant disruption to space infrastructure. Space agencies around the world would need to work together to track the debris cloud and potentially maneuver satellites out of harm's way. Some satellites could be temporarily powered down or reoriented to protect their most vulnerable components. The International Space Station, if it were still operational during such an event, would likely need to perform emergency maneuvers to avoid the densest parts of the debris field. What we'd see through telescopes. For amateur and professional astronomers alike, the aftermath of such an impact would provide unprecedented opportunities for observation. Immediately following the impact, telescopes around the world would focus on the impact site, documenting the formation of a brand new crater in real time. This has actually happened before on a much smaller scale. On the 17th of March 2013, NASA recorded the brightest impact flash ever observed on the Moon from a meteoroid weighing about 88 pounds. The new crater from a 3I Atlas impact would be enormous and incredibly fresh. Unlike the ancient weathered craters we're used to seeing, this one would be pristine, with sharp edges and bright, freshly exposed material. The crater would have a raised rim composed of ejected material, and depending on the size, it might develop a central peak where rebounding rock pushed back up after the initial compression. The rays of ejecta extending from the crater would create a spectacular pattern visible even in small telescopes. These rays are made of material thrown out during the impact that landed far from the crater itself. Some of the Moon's most famous craters, like Tycho, have ray systems that extend for thousands of miles. The new crater would develop similar features, creating a dramatic change to the lunar landscape that would be visible for millions of years to come. Effects on the Moon's orbit and structure. One question that often comes up is whether an impact could knock the Moon out of its orbit or even split it apart. The short answer is no, not even close. The total mass of every single asteroid in our solar system combined is less than the mass of the Moon. Even a comet several miles across, while capable of creating a massive crater, simply doesn't have enough mass to significantly affect the Moon's orbital path. The Moon has experienced an enormous number of impacts over its 4.5 billion years of existence. Some of these events were extremely violent, reshaping its surface and leaving behind vast craters that can still be seen today. One of the most significant examples is the South Pole Aitken Basin, which stretches about 1,550 miles across. The collision that formed it released far more energy than anything a comet such as 3I Atlas could produce. Despite these powerful impacts, the Moon has remained structurally stable because its interior is dense and solid, allowing it to absorb immense force without breaking apart. If 3I Atlas were to strike the Moon, the results would still be scientifically important. The impact would form a new mass concentration, known as a mascon, beneath the crater as molten and compressed material cooled and hardened. This denser region would slightly alter the Moon's gravitational field, creating small variations detectable by precise instruments. Spacecraft orbiting the Moon in the future would need to take this into account when navigating or maintaining stable paths. The collision would also generate intense heat, melting surface material in the immediate area and causing temporary thermal changes. However, because the Moon lacks an atmosphere and has efficient heat loss to space, this warmth would dissipate relatively quickly. Over time, the crater would cool, solidify, and become just another feature among the countless scars that tell the story of the Moon's long and violent history. Scientific opportunities. While an impact would be destructive, it would also create an incredible opportunity for scientific research. Every impact essentially performs a free excavation, digging deep into the lunar crust and exposing material that's been buried for billions of years. Scientists could study the freshly exposed rock to learn about the Moon's internal structure and composition in ways that would otherwise require expensive drilling operations. The impact would also allow researchers to study impact dynamics in unprecedented detail. We'd have before and after images from lunar orbiters, real-time observations of the impact itself, and the ability to track the evolution of the ejecta cloud. This data would help refine our models of impact physics, which have applications for understanding everything from asteroid threats to Earth to how planets formed in the early solar system. Additionally, the interstellar nature of 3I Atlas means that material from another star system would be mixed with lunar rock. Future astronauts or robotic missions could potentially collect samples from the crater that contain this interstellar material. Imagine being able to analyze rock from another planetary system without having to travel light years to get it. The impact site would become one of the most scientifically valuable locations on the entire Moon. Planetary defense lessons. This thought experiment about 3I, Atlas hitting the Moon, teaches us important lessons about planetary defense. Right now, NASA and other space agencies focus primarily on tracking asteroids that could threaten Earth. But as this scenario shows, we might need to expand our thinking to include threats to space infrastructure and objects orbiting beyond Earth. The discovery and tracking of 3I Atlas demonstrates how far our detection capabilities have come. The Atlas survey system that found this comet is specifically designed to give us early warning of potential impactors. Newer facilities like the Vera C. Rubin Observatory in Chile are revolutionizing our ability to spot smaller and more distant objects. In just 7 nights of operation, Rubin discovered over 2,100 previously unknown asteroids, including 7 near-Earth objects. As humanity expands into space with more satellites, planned lunar bases, and eventual missions to Mars, our definition of what needs protecting will evolve. The potential for an asteroid to hit the Moon or pass through Earth's orbital space where satellites cluster becomes a relevant concern. This hypothetical scenario with 3I Atlas helps scientists think through these possibilities and prepare response strategies for future situations. While 3I Atlas poses no actual threat to the Moon or Earth, exploring what would happen if it did reveals the incredible forces at play in our cosmic neighborhood. From the spectacular impact flash visible from Earth to the potential meteor shower of lunar debris, from the concerns about satellite damage to the amazing scientific opportunities, such an event would be simultaneously terrifying and fascinating. The good news is that NASA's tracking is incredibly accurate, and we'd have plenty of warning if any object ever did pose a real threat to the Moon. Our planetary defense systems are constantly watching the skies, ensuring that we're never caught off guard by cosmic visitors, whether they're from our solar system or beyond. What do you think would be the most amazing part of witnessing such an impact? Drop your thoughts in the comments below.